2023, October 11th. This is Plutus PBL live coding, and we're looking at some contracts and dApps today. Basically, just going to do a working session, take care of a couple things that need to happen under the hood of Plutus PBL, and get to know these contracts a little bit. So this is actually the newer version of the Treasury validator that's running under the hood of the Plutus PBL course. And you can see there's a couple of things you can do from a treasury. But most importantly, anybody can come along, and if they hold the right contributor token, they can make a commitment to a project that's listed in the treasury. We're going to talk more about this newer version in the days to come. But let's go over to the course for just a second. To see, just remember what this looks like right now. When you make a commitment to any module, so for example, in module 301, there's this assignment here, and if I'm connected, and I don't know which one of these, yeah, this one has it, okay. If you're connected, you might be able to, this one has the module 204 prerequisites. Let's just go look at that one instead, because this token has not done that yet. Here we go. I can make a commitment. My wallet is connected. So here I see this button right here. Okay, that's fine. Hey, Mix. Now, when you make a commitment, you've maybe noticed that it shows up over here on the distribute demo. And this unlocking transaction, we call it the distribute transaction, is going to do two things. One, it's going to add a module to the list in your datum, and you'll get some test gimbals and test ADA too. And this is just because that functionality is there. One of the things we've been talking about more recently is separating those two concerns. There might be some cases where you have a learner in a course where you only want to update their list of accomplishments in that course, but not give them a reward for it. And there might be other times where there's just a project that needs to be done and you really only care about the reward, but you're not so concerned about adding a specific item to a list. We could even just count those completed commitments with a number, okay? But this original version has both. Now, when you go to make that commitment transaction, you can't just commit to anything, right? There's no such thing as module 900, for example. And I think a lot of you here, you could probably figure out the contract addresses in question. You could find the reference scripts, and you understand the concept that we don't need this front end to interact with the contracts that are running here. If you know Cardano CLI, you're going to be able to build a transaction that has you committing to any module you want. So we use a little bit of Plutus to protect the list of what modules can be committed to. Any questions about that concept? So let's look at what that logic looks like. And actually, let's look on chain first. So in the PBL course, let's trace this all the way. I'm going to go to the page for contributors. Well, no, it's really a commitment. I'm going to go to the component for committing to a transaction, or sorry, to a module in this case. And let's go down. We're looking at the TypeScript and the mesh right now, right? So there's a transaction we're going to build way down here. Here it is. And to build this transaction commitment, what are we doing? Well, we're going to unlock from the treasury a UTXO. We're going to send a UTXO back to the treasury, basically holding all of the tokens that are not in the reward for this commitment. We're going to send another UTXO to an escrow address that's going to hold the rewards for this commitment and your contributor token. You've probably noticed that after you make a commitment, you don't have your contributor token in your wallet anymore. That's because it's temporarily locked at escrow, where after we distribute it, it's returned to you. And then there's some metadata on this transaction, and we can keep track of that in the system. And we say the contributor has to sign this transaction. But really, this is it right here, right? One input from the treasury, one output to the treasury, one output to escrow. All right, so let's first look for just a second at the UTXO to the escrow. Where is this thing built? Up here. I'm just using a hook. I have this temporary value for it. It looks like this. Now we use partial UTXOs when we're creating outputs in Mesh, because there is no input for this UTXO we're making, right? It only has an output. It has the address it's being sent to. It's got the amount. And if I look at the type right here, maybe it has some datum on it, right? But we're actually going to handle the datum in the recipient. And we'll look at that in just a second as well. But these assets, okay, what's going in there? These are the assets. 2 ADA, 10, in this case, just test gimbals on testnet, and your connected contributor token. Here they are, right? Hard-coded, 10 gimbals, 2 ADA, and your contributor token. Right? Obviously, it's a much more interesting application if this number and this number can be dynamic. And that's like one of the essential things that's part of the more flexible Andamio platform. Okay. But for here, it's just hard coded. Okay, suppose that every reward is this right here. What about the datum for the escrow? How is that handled? Well, we have the value here. And when we're reading a UTXO from on-chain, it's nice just to grab the datum hash. And you can query this in like a GraphQL query. But when we're constructing new datum to put it on-chain, it can be really nice to put it in a certain format. All right, so what's that format? And how are we attaching it in the first place? Look right here. Send value takes 2 parameters. Newman, what's happening? Right, we got these 2 parameters, recipient and value. The value is the UTXO that we were just looking at, the partial one with only an output. But recipient can actually be a type like this. It could just be a string, only an address, or it can be an object that has an address and a datum. All right, so we're basically saying, here's the value we're going to send. Here's where we're sending it. And when you send it, attach this new datum to it. And this gives us a nice way to actually look at legible datum instead of just a byte string. So let's look at that, the constructed project datum. Where is that being built? This is defining a redeemer. We'll come back to that. We might not touch that too much today. But here, this looks good. Set constructed. Okay, so constructed project datum is a use state hook, just like a bunch of other stuff in this app, because it's right, it depends on the data being pulled in. But here's what the datum looks like after you make an on-chain commitment. Pub key hash of your connected wallet, the Lovelace and Gimbals, and the reward, some expiration time, and the hash of the project. Let's find this. Okay, I want to look at this data on chain. Now, to do that, I need to know what address we are looking at. Maybe I need to know the escrow address. Okay, and so that's pulled in. We have some configuration here, just at the root level, and this is part of the prototypiness of this current app. Okay, we're making the config experience a lot better, but this is a pretty good placeholder for now. If I go to the top level, here's my config, and there's just a mess of data in here. Okay, but it's actually kind of useful. Here's the escrow contract address. Right, this is what's being queried to show us this list of commitments right here. It's not showing us this bit, the contributor datum, but it is showing us that there are two commitments locked right now. Let's actually go over to GraphQL and query this address. So I'm just copying this from the repo in my GPTE config, query it. I expect to see two UTXOs here, and that's exactly what I can see. Right? Let's look at them. This one, it appears, here's the datum in question. Let's go back and look at that again. So in the, once again, in the front end code, we build this datum right here that has a constructor of 0. And then it's got a pub key hash, Lovelace, Gimbals, expiration time, project hash. Here we've got the constructor 0. And then we've got these 5 fields, just like we see over here. Pub key hash, Lovelace, Gimbals, expiration time, project hash, and this guy right here is, should be no surprise, is, whoops, I went the wrong direction though. Module 301, which is exactly what we see right here. Okay, the other UTXO, I would expect it to say module 203. Let's see. Bytes, there they are. This guy. And you can see right there that matches, right? So those are my two UTXOs locked in escrow. Martin, what do you think?
A constructor 0. Why do you need the constructor? What does it do?
Excellent. Let's take a look. All right. So by the way, it's called an alternative in Mesh. I'm not exactly sure why, and I don't know if maybe that might change in the next release of Mesh, but it's called an alternative here, and it's called a constructor on chain. Let's go to some Plutus code for just a second. And in this case, I'm going to look. I got to think about where that is for just a second. The old GPTE. I should have had this queued up before we started. No, that's an even older one. Where's this one?
Because a constructor is required, right?
Yeah, this will do. It is. And I want to show you exactly where it's coming from based on something you've probably already seen. So if I go to the types right here, here's those project details, right? Same as we were just looking at. Pub key hash, Lovelace tokens, expiration, and project hash. Now, when you define a redeemer, like this treasury action right here, maybe you've seen this in Plutus types, and if you haven't seen it yet, this is something we can spend more time on. But basically right here, it says make is data indexed. And we are associating each of these actions with an index number. All right. Typical to start at 0 and count up, but you could really make these any ints you want. I'm not sure. Mixer Adrian, is there an upper limit to what these ints right here can be?
Not that I know of.
Yeah, I'm
can,
not aware.
you can just choose whatever you want. I
Yeah.
think there is a limitation for the integer, which would be 2 power 31 minus 1.
So we're not in danger of running out of space.
Yeah, exactly. You can
Right,
go
so you
with
can think
2
of a billion
billion
different
something.
things. Yeah. Right, 2 billion. Your app can have 2 billion different endpoints is essentially what that means, right? Cool.
Exactly.
Not too worried about that. Right. So here it's explicitly stated, and this right here in a redeemer, if I want to make a commitment transaction, I need to use a redeemer to the treasury with this index right here, 0 for commit. But for a different transaction, the redeemer would say 1. And what that data type would look like, let's actually find our redeemers here. Where are they? Got some in this file. All right, so here's an example. You see this constructor 0 to the treasury, right, is because we're trying to make a commit transaction. And by the way, when we do make a commitment, we're not just saying, hey, I want to make a commitment. We're saying a commitment to what? Oh, to a certain project. And that's why this redeemer here has fields. Okay. But on the other hand, if I wanted to build a front-end UI for managing a treasury, you see how manage just stands on its own, just the action, right? Not the thing we are using in that action. Here, I would only need an index of 1. And so the way I would build that manage redeemer, I'll just show you by example right here, is it would look similar to this guy. Right, it's going to be a partial action because action can actually have some other fields, as you can see right here, but we only care about the data. The other things do come in handy, but I'm going to set those aside for just a moment and say, look, this redeemer right here, it's going to have data that looks just like the one above, but this time the alternative is 1, which is my way of saying manage. And the field, in this case, is just an empty list because there's no parameters to this redeemer right here. But that wasn't Martin's question. Martin's question was about this constructor here on our datum, which is not the redeemer, obviously, right? So where is that coming from? Well, in the Plutus code, it's unspecified. We're just saying that project details is a type that looks like this. And when we look at the actual—
You specified that, James, the line 68, but you didn't just put an integer for it. Like you didn't put the number, but this function by
Right.
default, it will add the integer or index to it. But if you want to do it by your hand, you need to use function line 74.
I could replace this line 68 and explicitly say what
Exactly.
index I want on that datum. But since I didn't specify it, it defaults to 0.
Exactly.
Yeah, good. Oh, yeah, I didn't realize that about this line. That's what that's doing. That's good to know. Okay, so if for any reason I wanted to be able to use an index other than 0 right here, I would just replace this line with a line that looks like this. And I would say that project details has whatever index I want.
Exactly.
Cool. These indexes come in handy when you have alternatives, right? And it's possible to write a validator that takes one of several sorts of datum, just like we're saying this one takes one of 2 different kinds of redeemer, right? But since my datum is always the same, it's project details, you can take the default route and end up with the default 0 right here. But this data type, alternative and fields, is exactly what I see when the datum is built. Let's just put this like this, right here. Right? There's our default constructor of 0. So far, so good?
Yeah, but if you guys want to go a little bit deeper about this constructor, we can deserialize CBOR code of a transaction, and inside that we can see actually what this constructor means. But that's a deeper level. If not, we don't need to.
Well, by the way, let's just look at this real quick, right? So this guy right here, we're seeing like a readable version of the datum here, but we also have the byte string. If I copy this byte string and bring it over here, there it is. Oh, that's the datum, right? So this is just a straight legible.
But do we have the transaction CBOR, James? The transaction CBOR. Yeah, the whole thing.
Let's finish. Let's come full circle to that. Yeah,
okay.
You can do that.
Sure.
Okay. But first, before we get there, the thing I wanted to take a look at is, okay, we were just looking a little bit at escrow, but what I really want to look at for just a moment is the treasury. These are our types. Let's go into the treasury validator for just a second. And the treasury validator, of course, it takes some treasury datum, and we call it DAT right here. Okay, so if I search this document for DAT, we get all these, that sucks. Let's see. Where is DAT? Check datum. Let's actually search for that here. Am I in the treasury? Oh, this is it right here. Okay. So yeah, this is, first of all, this line right here, check datum, is just guarding against the case where the student who is making a commitment tries to change the treasury datum, right? Anybody with a contributor token should be able to spend from the treasury, but shouldn't be able to change the datum that's there. Okay. And then down here, what we do is we look at the outgoing escrow datum, and we make sure it's matching some project details. But this is the part I really wanted to show you. Check that the project hash in the redeemer, the thing I'm trying to commit to, is actually in the treasury datum. This is the guard right here. So project details sorry, project hash B. All right, what's B? B is the parameter on our commit redeemer. So I say index 0 commit to what? To B, to this project. Or B was for bounty back when we were calling them that. Okay. And so in B, what data is there? Well, one of the things, as we just saw in the type, is the hash of the project. So let's check that that project hash in B, what I'm trying to commit to is an element in the project hash list of DAT. DAT, remember, is the treasury datum. Treasury datum, let's go back to the types, looks like this. Here it is. Treasury datum has a list of possible projects. And then this is, we don't really use this too much in the logic, but we just put like an issuer token name there. So what I want to do next is query the treasury. Martin, what do you think?
Yeah, I get it that you use the constructor to do multiple functions in the same contract.
Yeah, it gives us a way to like think about our endpoints and those, yeah, those redeemers. We should look at the CBOR for a transaction so we can see where those redeemers go. That's actually pretty interesting. Let's try to get there today. Back to my config. Here's the treasury address. I'm going to take that treasury address and bring it over here and query it. How many UTXOs in this treasury? Just one. This is this app is not designed for like 7 students to all try to commit to an assignment at the same time, right? We're not handling concurrency issues. And speaking of things to specialize in, that's going to be a really exciting spot to get to. For now, we just say, oh, there's one UTXO at the treasury. That's enough based on the cadence of how people are committing to things. This treasury, it's got, it looks like it's got 69 test ADA in it right now and a little over 8,000 test gimbals. But more importantly, it's got this datum. What's this datum? It has a list of byte strings that represent the projects that people can commit to. And if I look at that list, this one, these ones are a little longer. Watch this. Copy that guy over to here. The first thing we allowed you to commit to, remember, was module 103 with, or the second one. Or without GitLab. And then the rest of these are pretty standard length. This one, hopefully no surprises, is module 201, and so on and so forth. You can see, right? 32, 30, 31. And then we've got 202, 203, 204, 301. This one was an unusual one that was here just for fun. OG limited edition, just so we can play some games with that. And then let's go here. What's the last item in this list? Oh, sorry, no, that's the name of the token. It looks like the last thing we have right here is, yeah, 301. I just said that. And then we got that OG one. But module 302 is not yet in this list. And so that's why, Claudio, it's the commitment to 302 is not working. It can't validate because we haven't updated the treasury yet. Let me pause here for just a second. The next thing we'll do is we'll update the treasury, but does anybody have any questions about that stuff? All right. I've been.
Maybe about the structure of the contract.
Yep.
Like, I'm not completely visualizing the contract address stays at the same place, but it's hard to not to see the complete picture of the transaction, where the contract is going. But yeah, it's going to also to a new UTXO after you do these transactions, right?
Yes. Yes. Yep. No, that is the perfect spot for us to be right now if you're building a mental model of that. Let me go back. There's a few ways to look at this. We could look at like the Cardano CLI version. Oh, Claudia, thank you. That's awesome. This, I recommend if you are interested in building in the front end, just getting used to this structure right here, starting to be able to look at this piece. I instantiate a new transaction with mesh. And then what am I doing with that transaction? I am gathering inputs and outputs as needed. Similarly, you could practice visualizing the same transactions with Cardano CLI, right? Especially if you're not so interested in the front end or the mesh side, doing this exercise with CLI is equally valuable, right? And especially once you start looking at transaction building in two ways in parallel, right? Here's the Cardano CLI version, here's the mesh version. I can see the similarities between those. One of the differences is that when I build a transaction in mesh, I don't have to specify the exact UTXOs I want to consume from my connected wallet, right? If I was building this with Cardano CLI, you would see more of those inputs specified, and you might see a change address, right, back to the sender. Here, we don't see that because that's all automated by building this transaction. If I want to send, for example, my contributor token to the escrow, right, which is what this is going to do because that's how this bit is defined up above. We just looked at that. Mesh is going to consume the UTXO in my browser wallet that has that contributor token in the first place.
How does Mesh know the UTXO of the contract address? Because you don't specify it.
Excellent. Okay, let's look at this one. So the one I'm trying to redeem, right? What UTXO am I trying to unlock from Treasury? It's defined here. Let's go find it. So all of this use effect is happening after that Treasury contract UTXO is built. So I'm going to keep going up the page. Here, this says set Treasury contract UTXO. And we have a helper function that says GraphQL to mesh UTXO that takes one input or one argument. This is from our context, the current Treasury UTXO. Now I want to show you this without getting too bogged down in some of the the context stuff, because actually this is a primitive implementation of a context. And we can, if you want to go deeper into this React side, we will. But for now, I'm just going to say, look, PBL context is instantiated here. We have a site level context that holds a bunch of information about the application. Okay. And so let's first look at the context so we understand where this Treasury UTXO is coming from and what it is. And then we'll look at quickly how this helper function works. Let me jump over to this file. And this is just source. This is at the top level source directory of the app. right? So we were just looking at some components here. And now we're looking at the context directory where there's only one file, PBL context. Okay. And basically what this allows us to do is at a project level, have a bunch of information just ready to go behind the scenes. And the one I'm interested in is the Treasury UTXO, which of course starts out undefined, but it has this type GraphQL UTXO, which hopefully that kind of makes sense because look at what we're going to try to do with it. We're going to try to take a GraphQL UTXO and turn it into a mesh UTXO. Oh, good. Treasury UTXO, its type here is defined as this. But where do we get it from? Well, we set up a hook, current Treasury UTXO. And where do we set it? Let's find. There's only two occurrences of this in the file. We define it here and we call it here. Set Treasury, current Treasury UTXO to some kind of datum. And because of the way this app is built, right? Remember we looked at the Treasury over here only has one UTXO in it. There it is, index 0. That's why we're able to safely hard code a 0 here. But keep in mind, this is only the kind of move you make when you're building a prototype. If the goal was to build a more robust app where a treasury might hold more than one UTXO, for example, we wouldn't be able to do this little hard coding thing, okay? But when you're in the early stages, just trying to get something to work, sometimes you'll end up with something like this. Okay, so where's data coming from? If data do this, but where did we get it? Here. All right, here we're using the use query hook. Where'd that come from? That is imported from the Apollo client library, which is what we're using for this application. Okay. There's a bunch of different libraries that you can use in React for managing data. We'll look at a different one if we start going deeper into Andamio together. Okay, but in this case, we're using the Apollo hook, use query, and you can look that up. The documentation for Apollo client is really good. You could just search for that on the web. What's the query? Oh, it's a Treasury UTXO query. Damn it, where's that coming from? Okay, let's find that. That's imported up here. What we do is we can separate our queries into a separate directory, in this case, source data, right? So I was just looking at some context, but right next to that, here's some data, and this is a query, and we want the one for the Treasury query. And finally, here we come, full circle to just a GraphQL query that actually is very similar to the one we were just playing with over here. This one has the script and hash on it. Okay. Whoops. Right. But other than that, this query over here is exactly the same. Just doesn't have the script part at the bottom. Because I know there's not a Plutus script attached to this UTXO. And even if there was, it's irrelevant to me in this case. But I am curious about the datum, for example. So we have that right here. So we can define a query, once again, using an import from Apollo client. This is called like a string literal when you wrap it. These are not quotation marks. These are the backticks. On my keyboard, they're next to the 1 in the top left corner. Okay. And then inside those backticks, we can write a GraphQL query just like this. Okay, so that's the definition of the query. We pass that as an input to this use query. It has a variable. What's the name of the variable? Contract address, which is exactly what we see right here as the variable name, contract address. And what's the value of it? Oh, it's the Treasury address from our configuration. So this is where the data initially comes from. And when we get it, it's in the form of GraphQL data. In other words, it's going to look pretty much like we see right here. I can get rid of this part if I want to, right? Just delete that. And the query still works. Okay. So this is the raw data that we're pulling in, but it's unruly, and maybe we want to clean it up a little bit, especially if our goal is to have a mesh UTXO. And that's finally why then over here, we say, okay, well, in our site context, we have a treasury UTXO. It might be undefined if there's not one or if there's a network error, but as long as we're able to make that query, now we have a GraphQL UTXO, which once again is going to look something like this guy right here, right? There's the UTXO. So actually, let's look at that type for just a minute. This is defined in source types, GraphQL. And we have this GraphQL UTXO, which I'm just going to go a little wider screen for just a second here, right? This GraphQL UTXO, what does it have? It has a TX hash. There it is. It's got an index, right? So we're just building a type that matches the result of our GraphQL query, right? Maybe it has datum. If we search for that, maybe it has a script, right? This one has datum, but remember, we just got rid of the script over there, so it doesn't have that. That's why there's question marks, okay? And then we can define some of these other bits down here. So like the GraphQL token, right? We have a list of tokens right here, right? And it's a list. What is a token? It's got to be an asset, okay, and a quantity. Asset and quantity. And in this case, we're only looking at the policy ID and asset name. Policy ID, asset name. We left out asset ID and fingerprint because they're not being consumed in this application, but they could be. So now we've got this data. We are able to check against it. And once types, this is the best thing for anybody who hasn't really gotten into TypeScript yet. It takes a little bit of work to build the types. But once you do, you get the benefits, for example, of being able to just mouse over. Let's go here now to this helper function, GraphQL mesh UTXO. And because I've defined in my types what a GraphQL UTXO is, that's why I can mouse over it and see this nice explanation. And I can also, you know, once I'm looking at it, so UTXO from query right here, if I just say const example equals UTXO from query, and then I type a dot, see that autocomplete right there, right? That's TypeScript. That's because I defined the type. And now I know that a GraphQL UTXO has these fields, and that's where I can get the beautiful little autocomplete that's so helpful right here, TypeScript. Okay. But I just have a helper function right here because one of the common things I have to do in an application is take data that might look like this and turn it into a mesh UTXO, which looks like this, right? It has a type as well, input, output. Input has an index and a hash, right? TX hash, TX index. It has the address that it's going to. It has all the tokens in the output. And maybe, look at these question marks, maybe there's a datum hash, maybe there's a Plutus script. No, sorry. Maybe there's a datum hash, maybe there's data itself, and maybe there's a reference to a script that's on chain. Okay. In this case, we've got some datum. These are the bytes. This is that byte representation. Let's go back over here for a second of this datum. All right, so yeah, I'm able to read the datum in this value bit over here, but also it's enough if I don't need to change or read from this datum in any way, I can just grab this byte string, which remember, just decodes to something like this anyway. But in terms of the mesh UTXO, all it needs is that byte string. Okay, same data, just a different format. So now finally, that brings us to the answer to Martin's question. Okay, so where is the Treasury UTXO coming from? It's coming first from a GraphQL query, which we store in the app context. So it's usable without re-querying across the project. And then we take that raw data of a GraphQL UTXO and we put it in a nice mesh-friendly format so that finally, when we set, right, when we look at this Treasury contract UTXO, here's the hook that's being set right here. What data type does it expect? A mesh UTXO, right? And so now when I look at that Treasury contract UTXO, oops, I can, for example, consume it when I build a transaction. Okay, so I've dynamically pulled the data and then processed it into the format that redeem value takes. Redeem value takes a value, which is a UTXO. How's everybody feeling? I don't know if that's too fast paced or if things are making sense, or what questions do you have?
Very nice. Yeah, that's very illuminating. Another question. When do you trigger the set treasury or the GraphQL query? When do you?
Beautiful. Okay, so that's a perfect React question, right? What you're going to see often on a page like this is use of use state and use effect. There are other ways to do this, but for people who are getting started with React, we really wanted to expose you to use state and use effect. Let's look at these, okay? So these are, the use state gives us a way to have variables that might update dynamically, right? And the one of the core innovations of React, and this is, common now. We all know how web applications work, right? If a little bit of data changes on the page, as a user, I don't expect to see the whole page reload. I expect just to see the little bit of data that's changing change. That makes it feel more like an application. If every time, a token price changed on a DEX, the whole page reloaded, I wouldn't feel like that was a great user experience. And so use state is one of the key tools that enables that. We're able to say, okay, there's going to be a bunch of variables that change. Use state takes a list of 2 items, right? A tuple, right? The variable and the function that's being used to change that variable. Okay, so in this case, I don't know the contributor's address yet, but if a wallet gets connected, then I'll be able to set the contributor's address. So let's see how that works. Well, up here, Mesh gives us this use wallet hook, which exposes a couple of things. Among them, a connected, right? This is a Boolean, true if there's a wallet connected, false if not, and a wallet. And then it actually, there's a use address hook that we're not even using here because we wanted to show you this. So actually, this is a nice little Easter egg. So basically, what I want to do is change this value anytime I know there's a wallet that's actually connected, right? And what I just described there, see you tomorrow, Newman. What I just described there is why use effect exists. Basically, what use effect says is if something changes, right, at the end of this use effect, which is all right here, when PBL context changes, we're going to run this function. Let's see, can I find a place that has connected or wallet in the list of changes? Treasury contract, datum. Connected UTXOs. I'm not going to search for, I'm just going to search for where this guy is called set contributor address. That's called inside of a use effect. Oh, and we don't even bother doing it until connected UTXOs changes. Oh, right, of course. There's a few reasons for that. But the point is, I'm just trying to give you a quick overview of use effect, right? I can create functions that run. This is just an anonymous function, right? That has this stuff going on. And this runs anytime this thing changes. So, for example, your question directly was about, say, the Treasury contract UTXO, right? When is that queried? Let's find this. Oh, this happens inside of this use effect, which is called anytime any data in the PBL context changes, okay? PBL context actually also has some use effect hooks in it, use state and use effect. So when is this one? Set current Treasury UTXO. When is that one called? That's called, once again, when data changes. What's data? That's actually from another hook, this time imported from a third-party library, Axios, right? And so this query, we want this to run basically anytime the site loads. Okay, there's no use effect wrapping this guy right here. Basically, anytime you load the application, we're going to get some data in the background. There's better ways to do this if we were fine-tuning the application, but at a high level, the concept here is good, right? If I'm using an application and I go to the home page, by the time I click to the next page or the page after that, I might expect the page to just load up, right? That feels really good if I don't have to wait for it. And by preloading data into context like this, you can make it nicer performance, right? Okay, we've already got that data, so we're not going to have to watch it load. And that's kind of actually, you can see both sides of this in action over here. Let's refresh this. If I go back to this contributor list again, you see how when I loaded this page, that whole wheel spun? That's because the whole application is loading some data. And if I go to the distribute demo over here, watch really closely. When I click on this page, it's actually gonna already know that there are two UTXOs locked in escrow, but it's not going to have the data of each of those yet. Watch this, ready? Loading, two empty boxes. Do you see how there were those two wheels running right here, right? So it already knew there were two UTXOs because it already knows that from site context, but the data itself within these boxes had to load. So we load the context and then we load each of those. And then even this data populates even after that, right? So you can kind of see the waterfall of different data coming from different places.
So if multiple users were interacting with the contract, it could be possible that the UTXO is not there anymore when you press distribute.
Exactly. 100%. Well, so the distribute is not really a problem because actually each of these is a unique UTXO at the escrow address. But the problem that we certainly have not solved for in this application is what happens if two people press the commit button at the same time. Okay. Right. So here, this commit to module 204 button with here, we're looking at the source code for it right here, commitment TX is going to fire the building of this transaction. Where is it? Here, right? We're going to build this transaction, which does what? Oh, it unlocks from the treasury. Oh, wait, how many UTXOs are there always at the treasury? In this case, one, right? And that can only be spent by one person. So if two people try to commit at the same time, yeah, one of them will get an error right there. Or if the data in your context hasn't updated yet, right? Maybe you loaded the site 5 minutes ago and there was no hook triggered that re-queried that treasury address. And so while you were sitting there navigating the site with this treasury UTXO already loaded into memory, right? Somebody else makes a commitment. Well, now the treasury UTXO that you have in your browser session is no longer valid, right? But though these are exactly the kind of performance things, I've been looking forward to talking about this stuff for so long. Maybe you can tell. Like these are the kinds of things that we can look at together. Hey, what are the options? Concurrency. I've heard that word. Let's look at that together, building from this primitive example.
Yeah, so yeah, in that case, you would have not 0 contracts, but maybe multiple. You could do that.
Right. If I want to build an application where I'm expecting to have 10 students at any given moment committing at the same time, I have two options. I probably have more than two options, but at least two. I can predict the maximum load for my system and just try to build it so that I always have at least that many UTXOs in the treasury, right? Or I can build some kind of service that waits, that creates a queue, right, for people who want to make a commitment. And if that queuing service sees that somebody else has already spent the treasury UTXO, it waits for the prior transaction to be confirmed, and then it allows me to build the transaction with the next one, right? And what I just described opens up a whole new set of interesting design challenges, but they're all things that you can work on, right? And we looked at Maestro a few weeks ago. Maestro has, for example, the transaction monitoring service that would be a key tool in allowing for that functionality.
Oh, because otherwise you would need to have your own server to do Sunday Swap has the batcher. This is like a batcher, right?
Sure, right. And that's an option too, isn't it?
And then you need to, but Maestro can help you with that so that you don't need backend services.
For example, yeah.
Cool.
Hopefully you're wondering, wait, when do I sign the transaction? Right? How do I give my signature for a transaction where I'm not actually sure what the input TX hash is going to be? But we'll get to that. And we are going there. Okay, my goal was to look at, let's take just a minute to actually update this treasury datum so people can commit to module 302. And actually, by the way, 303 is now live with everything but the assignment. Shout out to Agustin, who built these videos and built some pretty incredible lessons. And I think this is our first meme of the course. I don't know why it took this long to get a meme into PBL, but now it has happened. And so we've got these lessons. The assignment is not up here, but let's just add module 303 while we're here to the treasury so that when we're ready, people can commit to it. Yeah, there's some fun unanswered questions about Aiken. Augustine and I were talking about this. We're excited to look at these together when the time is right for this group. No hurry, but we'll get there. But the thing I needed to do, I actually, I have this somewhere, but I'm a little bit disorganized at the moment, and I need to figure out what instance of GPTE we were using. Give me just 1 second here. This is probably this one. Let's see. Maybe. No, that's cool. What? Sorry, give me just a second. I've been meaning to do this, and I just am a little disorganized on this machine right here. I need to find which one we were using. It's this guy. I was in the right spot. I think this is it. Hopefully, we'll find out. Here's how we can check. Sorry about the delay. The question is this treasury address the one we were just looking at? I think it is. Yeah, it is. Okay. Good. And this is the escrow address as well that match our config. Ending in VLD3D for the escrow. Yeah, good. That's the right escrow address, and that was the right treasury address. Great. All right, so this is the repo. Now this thing has a funny little script in it, but it should look kind of familiar. We've got a script here called update treasury datum. And so it's going to ask me to pass it the issuer wallet, which is already a project variable. Great. Okay, this should just work. Yeah, this was built just to work. But we need first to define the new datum. So here on line 66 of this script, we're saying the new TX out, the new treasury TX out has a new datum file. There's also a redeemer action file. Let's look at that too. So where are those defined? The redeemer action is in the same project path scripts redeemer manage. And then we got the datum here. Let's look at manage for just a second. Remember, just a minute ago, we were looking at this type in the treasury. And this treasury action, manage, remember, was index 1. So if I look at the redeemer for manage, this is what I expect to see. There it is, constructor or alternative 1 with an empty list. So hopefully that matches expectations from earlier. Manage looks good. What about the datum? Here's the datum treasury. Yeah, we want this guy. Oh, that's not up to date. I wonder why. Well, hopefully this just works. So let me go over here. I'm just back in the GraphQL query over in my browser, copying the list of byte strings so I don't have to type them all again. I'm just going to drop them right here. Oh, wait, but I only want these. Sorry, just that list here. There we go. So here's 301. Let's just make 2 copies of that. And we'll have 302 and 303 now in our new datum. Good. This guy doesn't change. Yeah, good. All right, so that's saved. So we got the datum and we've got now this script issuer updates treasury datum. I think I've just got that wallet set up. So let's just see if this works. I have a preprod node running and it's synced.
Manage is manual.
But
The manage is not via the site.
it's not yet, but we've kind of part built it a few times, but as we started updating the contracts and decided it wasn't worth it to add it yet to the front end, but in the process right now. And that would be a fun project. If anybody wants to do that together, that would be a great way for all of us to learn more about transaction building together. Yeah. All right, so I am now in this directory. Copy this path, CD to here, and then CD into scripts. This, and I want to run this issuer updates treasury datum script, which now that I know that the datum file is up to date, I should be able to just run this thing. Oh, why did it fail? Let's see. Oh, that validator doesn't exist. Oh, was I using this? Why is that the name of it? GPT? Oh no, I think maybe that just hasn't been updated. P2. Yeah, let's go output this. Let me just change those names. I think those are in my instance. Yeah, that version. So I'm getting these errors because the file names that you can see like here and here don't match the file names we see here. But we know these are the addresses that we want. So really, I'm just going to change these file names to match these guys right here. So copy this name. And that's my escrow. And copy this name. Let's see if that's enough. That might just work. Still doesn't like this address output. Address. Oh, I like that. This is such a neglected little repo. Thanks for your patience. Let me do it this way. We've kind of started putting efforts into the next things and kind of let this slide a little bit, but oh, these are just, yeah. Those errors are actually irrelevant to us. This is fine. So I have this address here. I know I've got, I don't need to fix the rest of that. I know that, let's go over here for just a second to the source code for these contracts. And we're going to go to the compiler for just a second. When we compile the treasury, we have to specify the policy ID of some issuer. And this is the token that's allowed to update the treasury. And you can see that the wallet I have loaded up here has a token with that policy ID 15A9. That's row 9. And then we have the option of adding more gimbals to the treasury. Sure, let's do it. Let's add a few more of these test gimbals here. Those are in row 4. And then I need my issuer token. Oh, whoops, I did it wrong. Got to start over. The first one was asking me for a fees UTXO. I want to use one that just doesn't have anything extra, like this guy right here. This should do 9.2 ADA is plenty for fees and collateral. So row 2. And then the one with T gimbals, once again, I can use row 4. It's got 1,000 test gimbals in it. And then row 9, that's the one with the contributor token. Okay. Treasury UTXO is at this address. Here we go. There it is, right? Here's the current datum. You can see it down here, but it stops at module 301. It's got this OG guy right here, but there's no 301 and 302. There's only one UTXO here, so I just want row 1. Lovelace, there were 69 ADA. Let me just add 1, round it up to 70. And I had a UTXO with 1,000 more T gimbals in it. Let's round it up to 9,000. So what do I need? 778 more. Yeah. But I should be able to just type 9,000 here. Why didn't it work? What isn't it like? Option TX out. It saw an unexpected plus. This TX out doesn't have an address. That's not going to work. That one looks good. Oh, and it's adding cumulative. Cool. So let's go back to that script for just a second. Yeah, this is a little embarrassing that I've been neglecting this so much, but you get to see the real thing. Treasury address, why? I input that when it asked me for it, but it doesn't seem to be pulled in correctly right here. Why? There and there, project variables. Oh, it didn't like this part. All right, just to save time, make sure this gets done. I'm going to just grab this address directly, and I'm going to drop it into here. I might break something else by doing that, and then I'm not gonna make the sum. I'm just gonna say how many more of each token we want. Forgot about the usage there. Try one more time. Let's see. So UTXO2, and then UTXO4, 9. Let's use that. Let's just add 1 ADA. And let's just add 778 gimbals. And this input is not available. Which one? 2A. Hey, I just got kicked off. I'm not sure why. Can you guys hear me?
Yeah. I do.
Hey, sorry.
Problem.
Sorry, I was apologizing. I was not really ready for this today. And I wish I had just taken like 15 minutes to prepare to do this live today. But I'm a little bit disorganized right now. And I gotta just go through and find where I left these scripts. Because
We can look to this tomorrow if we don't have any other plan. I mean, regards to module 302 or 303. I don't know. Do we have a plan for tomorrow? If not, we can continue.
Yeah, not at the moment. Not at the moment. And I do want to do some talking about how we spend time, right? Like I think this is kind of a fun one-off session looking at a few of these things, especially with we've got a good crew here of people who have been really engaged. But yeah, and I can certainly be ready to quickly start and just show you this transaction. I'm going to wait till tomorrow to fire it off, but I'll be ready for it and just show you guys that, and we'll see the change go live. Okay.
Yeah, no problem.
But yeah, I just didn't. I had a little bit of housekeeping to do in order to prep, and I hadn't done it. So yeah, we could start with that, and then we can jump in any number of directions. I would love to. We'll see who shows up as always. And we'll take a few minutes to write down different things we could work on, and then we'll decide where to go.
Yeah, great.
Well, any remaining questions about what you saw so far? This fails, just this error that's on my screen right here. It says, right, the following TX inputs were not present in the UTXO. So this is the one I had been trying to use for the reference script, but apparently that got spent at some point. But actually, you know what? I could find that too. All right, hold on 1 second. Let's not give up. 4 minutes. Give me just 1 second. In the GPTE config in the front end, I think we define this reference UTXO, and we know it's working. So where is it? Here it is. Let's try this instead of that other 2A67. Let's just try. So I'm going to replace this as index 0 back over here in the transaction I was trying to build. It was using some reference UTXO treasury script, which is defined in variables, but the TXID I had right here is not correct. Let's replace it with the one that's actually in the front end, because we already know that one works. All right, good. Let's just see if that's enough to fire this transaction one more time. And we still want that one for fees and that one for gimbals and this one for authentication. And we're going to spend, replace that. We're just going to add one ADA. So there's 778 of those. So there's 9,000. And there it is. Okay. Just had the wrong reference UTXO. That didn't take too long. Thanks for your patience. And a fee, it costs 41 ADA cents, 42 ADA cents to update the list of projects in the treasury. And we can see that's already been accepted from my mempool. So if I now go back to the web browser and I go back here, where will I see that? I don't think we don't even have a place on the front end. Oh yeah, we do. We have here. There is one place to see this. Commitment demo. Here it is. Here's the list of all the modules you can commit to. And this is querying that datum that we just updated. And as you can see, now there's commitments available for 302 and 303. So we did it. So Claudio, that should work. And here is the Treasury UTXO. There's some dev stuff on this page. This is the live site. Contributors commit has just this little representation. But you can see now there's 70 ADA and 9,000 gimbals, just like we wanted. And there's our list. Sweet.
And if it is possible, can we deserialize that transaction, James, in the CLI?
Oh, great. Yes, we can.
Do you have that tool I was talking about? Like,
No, I got distracted playing around with my dev environment.
No problem. I think there are online tools, so we can just deserialize that.
Oh, where did I do that from? What directory was I in? I was in scripts, right?
Because in that we can see the datum redeemer, which actually the constructor, how your constructor can understand what is this constructor actually is and what does it mean.
Should we look at does it matter if we look at the signed or the draft transaction?
Signed would be better because we can see actually the sign, like where are the signatures. Like it has more data.
So Juan showed me just a fun way to play around with this the other day. You can go to the Seaboard Playground. And this is a little bit hacky, but it's kind of a fun way to understand how this stuff works. And I can drop that stuff in right here. I can convert it. This looks almost readable, but kind of confusing. So I'm just going to grab that and I'm going to bring it back to my editor over here and put it in, let's just put it in a JSON file. Let's put it here in notes. And then I can format as JSON. And so here's that. Yeah. That's a pretty good view, right?
Yeah. So would you come a little bit down, James? Down more.
He's right here. That's our
yeah, exactly. Line 81 is our constructor, guys. This is a standard. It is inside the CDDL, which is a standard documentation for Plutus that index for redeemer or datum start at number 121. Why is this number? Well, there is a long story. You guys can search about it, but this is it. So your contract, if you have something like constructor 0, your contract actually see that inside the transaction as the index 121. And if you add index number 2, 1, 4, whatever, it will be added to this number. So your contract doesn't know about the other things like the fields, all those things, but they track all these numbers. And all these numbers are actually hard-coded inside the Plutus code as well. So once you are trying to match these things, like the contracts say, check that I have 122, for example. Okay, I see 122 in this transaction. Therefore, I'm going to run these conditions or this set of logics. That's how all those conditions fall into the category of redeemers, like each redeemers we have, or datums. That's a standard inside the.
I recommend playing with this to anybody. Look at this list I have right here. It's got 4 items in it: object, true, and null. And I just dropped the CDL link into the chat. It's this right here. Look at a transaction. What is it? It's a list with 4 items in it: a body, a witness set, a Boolean, and this extra data that can be just null, right? So here's our Boolean. It's a valid transaction. Here's the null for auxiliary data. The 3rd item was the witness set. Here's our witnesses. And let's look at index 0 and index 5. So I can scroll down through the CBDL and I can find how witness set is defined. Where is it? A little farther down.
Yeah, put a straw witness, James. We can.
That's not it. No, that's not
No?
it. I'm looking for witness set. Witness. This is what I'm looking for. This guy right here, you see how we have this object that maybe has a bunch of different indexes 0 through 6, but here's the description of each of those things. And in our particular transaction, we only had indexes 0 and 5. 0 is for V key witnesses and 5 is for redeemers. As you can see right here, 5, that's our redeemer. And then you can look farther into the spec to see how redeemers are built. V key witnesses, that's because I defined the connected wallet as a required signer in that transaction. Oh no, sorry, that's just this was my CLI transaction, right? That's just we had to be signed by the owner of the UTXOs that we were unlocking, right? But in the very similar way, I can now look at this top object, which is where the really interesting stuff is. And this was called the transaction body. And it's got a bunch of different indexes, 0 and 13 and 18 and 1. And I can look once again over here to see what each of those mean. 0 and 13 and 18, right? And 1. So what, hopefully it's starting to be kind of reasonable what each of these is. We've got 0 as our inputs. What is 0? Oh, it's just a list of transaction hashes and indexes. These are the 4 inputs that were spent in this transaction, right? And what's 13? There's only one of those, but it looks similar. 13 is, oh, it's the collateral input. Yeah, I do want just one of those. And by the way, this was my fees UTXO. It's the same as the collateral UTXO right here. It's a nice feature. And then you've got 1 reference input, that's 18. And then this is the list of outputs. That's the kind of interesting part. And we see that some of these have some datum on them. Oh no, this is just extra tokens, not datum. This is datum right here. Actually, I could take this string. Let's take that string from right here. And let's bring that back over to our Cardano scan decoder. And look at that, there's the data. Okay, so you can see it directly in the decoded CBOR right here.
James, would you please deserialize it via that CBOR deserializer as well? Because again, that was showing very good, like constructors.
The Rust tool.
No, the online tools, the one that just we deserialize this transaction with.
This one.
Yeah, exactly.
What should I do?
Paste that datum, that CBOR datum.
Oh, just the datum. Yeah.
Yeah. Because I just want to show the other guys that there is that number again. That constantly see that 121.
121. Yeah.
It
Nice.
is constructor 0.
Nice. I love it, Martin. I mean, if you can read CBOR easier than CLI, you can start building tools in whatever language you want, right?
Yeah, I did that in Python.
I love it.
It is. I think it's easy if you're using a different language. It's easier to build a CBOR than interact via the command line with the
100%.
CLI interface. It's easier to make your own CBOR.
I love that. You know, Mix got me interested in Go along with some other friends recently. And I'm like, I just want to fill up my computer with helper functions in Go that do all these things.
Yeah, let's do it.
Yep. I love it. And Cardano serialization library, that's what it's doing, right? All it's doing is it's applying the ledger spec to all of these different scenarios, and then Mesh is just abstracting the serialization library a little bit. But we could build tools however we'd like to achieve those goals. I feel like every time we finish live coding, all I want to say is, well, I'm never going to get bored. We're not going to get bored.
Yeah.
Plenty to do. Cool. Yeah, let's think about where we want to pick up tomorrow. Maybe Mix, it sounds like you've got some ideas for like a deep dive, if that's the direction folks want to go.
Yeah, we can work on that escrow contract. I can give you guys some tips, like how we can get rid of that info function. You know, Martin, you were using like the structuring script context, so your code would be it would look better or easier. Yeah, we can just do some deeper Plutus stuff together. Why not? And using Gimbal Labs utils pack library, optimizing some contracts, looking into the Plutus core together, you know.
Let's do it. So decision tree, let's first get questions from students who show up. We kind of just jumped right in because we had a small crew here today.
Yeah. And actually I have some other suggestion as well. I wonder, can we create a transaction by TypeScript, or I mean something like maybe it would be even Golang, but TypeScript for now, and then somehow sending that on front end and using the wallet which was logging or connected to that front end and sign a transaction, or like create. So the whole idea is crafting a transaction in backend, sending that to front end, just the user sign it, and then submitting that.
Mm-hmm.
Just testing that scenario.
Yeah, to complete a loop there. That's a great one. Okay, keep that one in mind.
There is a function called partial sign in Mesh, which we can use that actually. But yeah.
What would be your go? Well, no, let's save that question. Okay, yeah, because I have to jump off.
Sure,
but yeah, I think that's a great, that opens up some really cool questions about testing that and what's like the easiest loop we can create.
Exactly.
All right, so we'll take questions. We'll see if there's ongoing questions about the Plutus and the Gimbal Labs Utils library. We can talk about signing transactions in places other than they're built. And then we've got Aiken on the horizon. Those modules are now up, and module 303 is part of the datum now, as shown here. So there's between those four things, that should be a nice menu to choose from for the next few weeks.
Actually, maybe there is a fifth one as well. Look into Maestro. To
Yeah,
that
love it, love it, love it. And that's a place where it's not really worth it to retroactively introduce that tooling into the PPBL course, because we're going to be, as soon as Andamio is ready, we're actually going to move the PPBL content over to an Andamio instance. But as we do that, looking at those optimizations together, that's going to be really fun.
Yeah.
Excellent. All right. Well, thanks for the adventure today.
Yeah.
I hope,
Thank you,
I
Jim.
hope
Thank you,
people
everyone.
have new questions. You'll bring them. All right, everybody. See you soon.
See you. Take care. Bye.
Later.